Our next speaker is Sandhya from IKEA, and this will be the last talk for this session too.
Hi everyone, I'm Sachidanandan. I'm working as a data scientist in IKEA in the recommendations team. I have my team members here, and whatever I'm going to present is combined between the four of us, obviously. So, I'm sure I don't need to introduce IKEA to you all. Yes, we have over 400 stores offline, and we are doing e-commerce in about 35 countries and selling over 25,000 products in each market. So clearly we have a lot of data in the stores which we have to bring online, and these days our efforts have been to how to bring the knowledge in the stores online and make the customer experience as enjoyable as what they have in our stores. So whatever strategy that I'm going to explain today is also well aligned with that. So yes, I'm going to talk about product recommendations, specifically design-driven add-to-cart recommendations. So here is an example. You have a sofa there, and these products are recommended, and you can see that they match in terms of style and of course in terms of function as well. So I'll walk you through some of the models that we have in generating these candidates. But before that, I would like to tell you a little bit about why we are doing it. Very relevant to the previous question. We have, if you've ever been to an IKEA store, you must have seen that we've not piled up furniture on top of each other. There's a lot of thought that has gone behind how the furnitures are arranged. There is a reason why they are put together. Most of the time, they're also sold together. So that means we do have some style signals in our transaction data. So this is an effort in bringing that knowledge online. And of course, when you show that, shows very style-relevant recommendation on add to cart, that's like when somebody has finished their purchase of a product, then the idea is that they get attracted to, and then they start their journey or continue their journey and explore more. So that's a bit of motivation on why we are doing style strategy, apart from all the user behavior modeling strategies that we have. So, when I say style, what exactly is style, or what do I mean by style? So, the picture that you see here is what we call an inspirational image. I'm sure you're all familiar with it. We have them on our websites. People do go there and get ideas from there, and you can see that the products that are shown below are the products that are featured in that inspirational image. So for us, any two products that co-occur in an inspirational image is the ground truth for us, for all the models that I'm going forward that I'm going to explain. I would say major part of the ground truth. So that is what we call style, and any positive example is the style combination that occurred together in the inspiration image. So now let's get into how we do it. So in the first approach, so we do have a couple of approaches. So before we start, I would like to tell you that these approaches are all candidate generation or retrieval approaches, and none of them are ranking. So ranking is done separately. We rank them based on different methods, but the topic of discussion today is going to be how to generate style candidates. So in the first model, we use products inspirational image passing through a pre-trained CNN. So you have it here, the whole architecture. So the product inspirational image is passed through a pre-trained CNN, and image features are extracted from the intermediate layers. So when I say pre-trained CNN, it's trained on an existing ImageNet model. And then image features are extracted, we get the nearest inspirational images, and then corresponding products form the style recommendation candidates. So I have an example here. So you can see that this product bed is featured in that inspirational image, and then the nearest inspirational images are extracted based on the features extracted from the pre-trained CNN, and we have those corresponding products there. So now we got style candidates for that bed. And they also match in terms of function. So this is live, and the results that I've shown here is from Germany. Excuse me. Germany, and you can see that this is the pop-up that you get on click of add to cart, and what you see here is a style-based recommendation. You can see that whatever you've added to basket, the recommendations that you're getting is goes well in terms of style to the existing product. So we're getting great numbers as well over there. In our second approach, what we use what is called a Siamese network. I'm not going to explain what a Siamese network is today in the interest of time, but we have a Siamese network with a custom CNN. You can see the architecture here. Here we pass the product images to a custom CNN convolutional network, and then what you see there is exactly the same CNN but with the same weight initialization, but you pass two different product images and extract features from the last layer, and then learn the distance using a sigmoid loss. So here 0 indicates positive example, negative example, and 1 indicates a positive example. So 1, as I already said, is put together by designers and also signals from the transaction data because we have them in our stored transactions. And 0 is, so I think it's difficult to get 0 because we need to know what exactly is a negative sample, what exactly cannot be brought together, so that's tricky. So what we've tried to do is like try to get the negative samples based on color, material, series, and then never brought together, etc. So this positive and negative sampling is very important for Siamese network too, so that there is a pattern for the network to learn. Then we extract features from the feature part of the Siamese network, and then those form our style recommendations. So the embedding space looks like that. And then here we can extract, so you can see that we can all of them have a representation, and we can extract the k-nearest neighbors from them, and those form our style candidates. So to explain it further, so here what you see is like please read it row-wise. So in each row, the products that are shown are good style combinations of each other retrieved from this model. You can see that multiple colors and as well as different functions come together. I hope you all agree that it's good style combination. So in the third model, it's exactly the same, same Siamese network with one modification of having a gram matrix layer. So quick definition of what gram matrix is. I'm sure most of you are familiar with it. Given a set of vectors, it's just the dot product of one of them, inverse of them. So if you consider the convolutional feature maps as a set of vectors, then we can derive the gram matrix of all of them. So now in this modified CNN, in the modified Siamese network, we have an additional gram matrix that is derived from each of these convolutional feature maps. And then now the distance is learned on the grams with exactly the same training data. So training data zeros and ones are extracted the way it was extracted in the previous module. So here are the results, and these results are also extracted from the feature layer of the Siamese network after getting the k-nearest neighbors. So here you can see that there is a difference. Instead of different colors coming together, it's actually different functions but similar colors. So if it's black, white pattern, then you get all black and white patterns, and if it's bluish patterns, then it's all bluish patterns, and so on. So here, the idea is that this gram matrix kind of extract the style of the image. So if you come across this neural style transfer algorithm, I'm sure most of you must have. So they introduced this concept of extracting the gram matrix of convolutional feature maps, so that style is extracted from the image. So we thought we'd use it and see how the results look like. So clearly, you can see that very similar styles are coming together. The advantage of this approach is that we can be very confident on the style. For example, if there is a basket and somebody's adding some black iron, maybe they have an inclination towards that color. So color is an important aspect of that style. So that is the assumption behind it. So these two approaches, it's not live yet. So we are right now putting it into production. And in the first model that I showed, I used to say that we have ordered it based on product co-occurrences and category co-occurrences, and then so we can have other ranking methods as well to rank all these. So once we have these tag candidates. So we have just begun, so that's like a few models that we have. We have just begun our recommendation journey in IKEA. We are very new, we've been working only for a year now. So we do have a lot of challenges. So first of all, we do not have enough inspiration images. That means we do not have enough designer input. So we're collaborating with them to get more inspiration images. And of course, we need them to be tagged with IKEA furnitures. So we are also collaborating with our visual intelligence team to automatically tag the furnitures in the inspiration image. We have some of our visual intelligence team members here. And of course, we need to experiment a lot. Is style recommendation really relevant for all the products? So that's a big question that we have to answer. For example, if you're buying a knife, I don't know if people do match their handle with the cutting board's color or something. I don't know that. So I don't know if people buy like that. So there might be like many other electronic items which doesn't require style. So we have to identify those products which actually need a style recommendation. So that's one challenge, and then of course we need to have a better context identification. So here what I mean by context identification is that today we have models trained specifically for different rooms, especially because we have room-based inspirational images more. So we have those different models, so that means if there is a furniture that can fit in like multiple rooms, then that means we have to search multiple editing spaces. So that's an important topic that we have to tackle, identify the right context and show the most relevant stuff as the next basket recommendation. Then of course we need to find the path from global to local to personal. Today all the inspirational images that are shot are globally. We need more localized content because we need to respect the cultures and styles of the different markets that we are venturing into. And then, of course, style can be very personal, so personalization is also a very good next step. So these are like some immediate next steps that we have. So I hope you all enjoyed the presentation. That's it from my side. Thank you so much for listening.
One more question here.
Thank you so much for the talk. Here. I was wondering, how do you, when do you apply these recommendations? Do you take into consideration at all the user's history, buying history, or what they've seen on the website, or is it only applied based on the current item that they're viewing on the site?
Thank you. As I said, we have some store data and the signals online for this particular candidate generation we're not using, because the whole purpose of this is to bring the data, the knowledge from the stores. So in the stores we have transaction data and we do use that. So we know what products are being brought together, and we do, when I say we have training data from the transaction, I mean that we extract the stuff that has been brought together like a cut-off number of times as our training data. So yes, we use store transaction data, but for this effort we don't use online data because the whole idea is that style is incorporated in the store transactions.
Some questions, but I think I want to conclusion. Be fair for all the speakers. They are around during the coffee break, so feel free to the speakers in the question. Thanks for everyone. This talk concluded our session.